Hi students, it's Miss Murphy, and today we are going to complete the 2-for-1 activity in Desmos in regards to quadratics. So we have a function here, 2x plus 1 times x minus 3, and we are to calculate, this is called f of 1. So what that means is we're putting 1 into the function. That's why there's a f and a 1 in parentheses. 1 is the number that we will substitute in for all of the x's. So wherever you see an x, I'm going to start with Anaya's methodology first. Wherever you see the x, you can see she has taken the x away and put 1 in its place. X is gone, 1 in it is in its place. Now 1 minus 3 is negative 2. 2 times 1 is 2, plus 1 is 3. 3 times negative 2 is negative 6. She has her answer. Now Gabrielle chose to analyze each parenthesis group individually and then multiply those together. So, and there's a lot of mental math that goes on here. So Gabrielle's plugging 1 into this part. 2 times 1 is 2, plus 1 is 3, and just shows the number 3. Gabriel's also choosing to organize work in like a table fashion, whereas Anaya is working in function notation and working vertically. Okay, so Gabriel plugged 1 into the next group. 1 minus 3 is negative 2, and then took these two pieces and multiplied them together to get negative 6. So both methodologies get the same answer. There's nothing wrong with either methodology, and it's good to compare them. Okay, so we're going to sort the equations into 2 or more groups. It doesn't say specifically what kinds of groups we want. So I'm noticing that this equation here is in factored form, and so is function D is in factored form as well. These two are in factored form with the parenthesis groups. Here's another one in factored form. This is what we call vertex form. It is factored. The x minus 2 would be factored. I guess it's not factored completely, so I'll leave that one separately. And then I want you to notice these 3 functions over here are all in standard form, ax squared plus bx plus c. All of these are in what we call standard form. Now these 3 in the middle, they're kind of unique. This is exponential form below down here. This is linear form. And I mentioned this one previously. It's kind of factored, but this is what we call vertex form. So these are kind of like our oddballs. So I chose to organize my cards in standard form, factored form, and then whatever's left over. All right, we're going to do it again. We need standard form, factored form, and then anything else that's left over. So exponentials are not factored or in standard form. Linears, again, not factored. And then there was this, these are all the same function. So here's this vertex form. Factored form is with the parenthesis groups. And notice they're multiplied together. They don't just have parentheses. Like this has parentheses, but there's a plus sign. These are parenthesis groups. There's no adding or subtracting in between the groups. It's all multiplying. That's how you know it's factored form. Standard form is in the form ax squared plus bx plus c with no parentheses. That's all standard form. There we go. Okay, so let's see here. This graph has standard form and factored form with it. So standard form and factored form make the same graph. It's just, I like to say it's a way of like writing your name and then writing your name in cursive. It's still your name. So you can write a function in standard form or write it in factored form. It's still the same parabola. And then let's see here. I'm guessing factored form would go with this one. So notice the factors. Let's start with this first one. Notice the factor of +2 has an x-intercept of -2. That's a good connection to make. Over here, again, we have a factor of +2, an x-intercept of -2. This factor is -3, but we have an x-intercept of +3. And we could do that same thing for this one up here. So if we see a factor of x plus 3, then what we're looking for is the x-intercept of -3. And none of these have an x-intercept of -3, so this doesn't partner with anything. Um, but at least we know if we were to graph this, we would start with an x-intercept at -3. And then notice this parabola is facing downward, kind of like a frowny face. That's because it begins with a negative. The others don't have that negative in front, so they are smiley faces pointing upwards. Okay, so we have factored form, standard form. Complete the table and graph for each equation. So just to show you, I'm going to open Desmos. And I just want to show you these functions. Whoa, this is really big. Okay, that's better. Let's look at this first function. 2x minus 2, x plus 3. Now we know with this linear factor of x plus 3, that's a linear factor, we're going to see an x-intercept of -3. We learned that and talked about that already. If you're looking for a table of values, you can go in this settings button and click the table. And you have all kinds of inputs and their associated outputs. You can click down in the empty box below and enter more. So if x was 3, or if we plugged 3 into the function, we would get out 24. And you can continue hitting enter and have unlimited amount of values for that function. Now let's take a look at this other function. 2x squared plus 4x minus 6. And notice that. So if I go from the first one, it's red and then it turns purple. I like to click back and forth. And you can see that these two functions are equivalent because one is graphed right on top of the other. So this one's just in um, standard form and the other's in factored form. And you can even, if you're clicked in this box, go to that settings button again and click on the table, and you'll notice that their tables are identical. So you can compare the table values for as many functions as you need to. Okay, moving forward. Which equation do you think would be more challenging to graph? Well, I think standard form is the most difficult form of all the forms to work with because when you look at it, these numbers 2, 8, and 10, they're not really of any significant value when it comes to the graph. However, looking at factored form, I know that there's going to be an x-intercept of -5 just by looking at this linear factor. And so that gives me somewhere to start, a dot to plot on the graph, so it's a little bit more helpful to me. What makes the equation more challenging to graph? So um, having information like an x-intercept makes it easy, and without that information, I would have to do some more digging. I would have to maybe analyze the table of values, plug in zeros to get my intercepts, solve with the q of x part equal to 0 to get more intercepts. Once I do all that work, I would have the information, but it just takes a little bit longer. What advice would you give someone to help them graph an equation like this? Um, So I would plot the intercepts first from factored form. So this intercept will be -5. And then if you set this parenthesis group equal to 0 and solve it, you would be adding 2 on both sides and dividing by 2. So that lets me know I would have um, another x-intercept of 1. Um, so once you get the intercepts, you could graph those, and then you could plug in 0 for x, figure out what that is. That would give you a y-intercept. So you should have, in most cases, have 2 x-intercepts and 1 y-intercept. That gives you 3 dots to the parabola, and then from there you could kind of sketch a parabola connecting those 3 dots. Just a rough hand sketch. If you want a really super accurate graph, I would use Desmos. Graph it on the coordinate plane and show your thinking. So I would put a dot at 5. I would put another dot at -1. We're just visualizing here. So 5 and -1. And then if I put zeros in here, it's probably easier to put zeros in here. I would just get -5. So that tells me -5 would be the y-intercept. When you plug in zeros, that gives you your y-intercept. So I have a dot here at -5 and a +5. So my parabola should be kind of roughly right around this area. And we can take a look at that over here to see if I was right. So let's just kind of work with this one. X squared minus 4x and minus 5. So x-intercepts at -1, +5. You can tell what those are from the factored form, -1 and +5. And then plugging in 0 for the x's gives you -5. That's why the y-intercept is -5. And then Desmos is showing the graph, but if you were just sketching this by hand, you would put the dots in those 3 intercept locations, and you would just connect them with a smooth curve. Now, the 2 on the x-axis are very helpful because that kind of tells you where the center is. I know the center of this graph is at 2 because it has to be equal space from 5 and -1. So 2 would have to be what we call the axis of symmetry, or like the midline, if you will. And that helps you visualize where the parabola is going to go. I also know it's an upward facing graph because there's no negative in the beginning. All right, so best of luck in practicing your quadratics. I hope this helps.